Hi everyone, I am Jumana Khanfar from Taqarub International Schools. Today's lesson is about logarithmic functions. By the end of this lesson, you will be able to define a logarithmic function. And after studying the laws of logarithms, you will be able to simplify logarithmic expressions. And we will study the graph of a logarithmic function with some transformations. So let's start. A logarithmic function is a different representation of the exponential function. Y equals 10 to the power of x could be represented in a different way. It could be represented as x equals log base 10 of y. X is the power of 10 that makes y. For example, 1000 is 10 to the power of 3. So 3 equals log base 10 of 1000. 10 to the power of 3 equals 1000. So the logarithmic function is a different way to represent the exponential function. Let's graph this function and this function to see the difference. This is the graph of y equals 10 to the power of x. Now let's see the graph of x equals log base 10 of y. It is the same graph. So it's a different way to represent the same function. The inverse of this is x equals a to the power of y. Now let's represent the inverse with a logarithmic function. Y equals log base a of x. Let's graph these two new functions and see the difference. This is the graph of x equals 10 to the power of y. And this is the graph of y equals log base 10 of x. It's the inverse of the previous function that we graphed before, which is x equals log base 10 of y. They are inverse of each other because they are reflected along the line y equals x. Reflected along this line. So these two functions are inverse of each other. In order to simplify logarithmic expressions and solve logarithmic equations, we need to learn the rules of logarithms. Now, this is one of the main rules of logarithms. Logarithm base a or any number of 1 equals 0. Logarithm base 5 of 1 equals 0. Because 5 to the power of 0 equals 1. Any number to the power of 0 is 1. Again here, another important rule. Log base 3 of 3 equals 1. Because 3 to the power of 1 equals 3. Log base 10 of 10 equals 1. Or you can just simply write it as log 10. When you don't write the base, it means that it's 10. Equals 1 as well. So, okay. Also, when we have multiplication in the log, we can separate it in two logarithms with addition. When we have division, we can separate it with subtraction. Here. Now you need to focus here. Log base 3 of x to the power of 2 is 2 times log base 3 of x. So the power is a coefficient of the log. Same here. Log base, for example, 2 of 1 over x is log base 2 of x to the power of negative 1. and this power is a coefficient, so it is -1 times log base 2 of x. Also, you can reconfigure this logarithm by writing it as a division of two logarithms with the same base. Log 3 base 2 is, for example, log 10 of 3 over log base 10 of 2. Here we should write the same base for both of them. Now let's solve some questions about simplifying logarithmic expressions to apply these rules. Simplify the following expressions. Here we have two logarithms with the same base with subtraction here. We can represent them by one logarithm with division. This is log base 27 of square root of 54 over square root of 6. This is log base 27 of square root of 54 over 6 is 9. Square root of 9 is 3. So this is log base 27 of 3. The cube root of 27 equals 3. So the answer here is 1 over 3 because 27 to the power of 1 over 3 equals 3. Let's go to this example. The length is the log of base e of any number. So len x is log base e of x. So it's a specific type of logarithms. Here len 2x plus len 1 over x. We have addition and they have the same base, or they are both lengths. So we can rewrite this as one logarithm with multiplication. Len 2x times 1 over x. It could be simplified more, so it is len 2, and you can find this using the calculator. It's about 0.69. The logarithmic function is the inverse of the exponential. The domain of the exponential was all real numbers, so the range of logarithmic functions is all real numbers. Or from negative infinity to positive infinity. The range of exponential functions is y greater than 0, or from 0 to infinity. So the domain of logarithmic functions is y greater than 0. Let's prove this with numbers. Y equals log base 10 of x. The domain is the x values and the range is the y values. Can we substitute a negative value here? For example, can I say y equals log base 10 of negative 100? 10 to the power of any y could not be negative 100 because any exponential function does not give a negative answer. Now let's think about the range. Y equals log base 10 of x. Y could be a negative number because negative 2 equals log base 10 of 0.01 because 10 to the power of negative 2 equals 0.01. We can understand this more by studying the graph of logarithmic functions with different transformations. The graph of a logarithmic function is somehow like this. It approaches the 0 here, but it does not intersect the y-axis. And the x-intercept is 1 and 0. Because for y equals log a of x, a to the power of 0 equals 1. Let's see the graph with some transformations on a graphing calculator. Log base 10 of x. This is the graph of the logarithmic function, the basic logarithmic function. Let's zoom in to see if the graph intersects the y-axis or not. as y gets infinitely small, x approaches 0, but it won't be 0. Let's try to graph a different function. Y equals log x. Y equals log negative x. It's undefined. Y equals x to the power of negative 1. This is when the power is negative. So that's the graph of y equals log base 10 x to the negative 1. Let's graph now y equals negative log x. It is reflected in the x-axis, reflected vertically. Let's see the graph of y equals negative log of x to the negative 1. This is the graph of y equals negative log x to the negative 1. We got the same graph as the one at the beginning because it's reflected twice. This is enough for today. In the next video, we will solve some exponential and logarithmic equations and see the relationship between them. Thanks for watching.